Okay. Good afternoon. So today is the last lecture of this week, and we are going to study debugging and I/O. So by now you have written relatively complex programs in which you probably have struggled finding errors. So in the first lecture, I told you that you need to focus on two things. The first thing was the syntax of your program, and the second was what you actually want your program to do. And if your program has syntax errors, then MATLAB can find those errors at runtime. So let's assume that your syntax is perfectly right, but the program is not doing what you want the program to do. And that's wrong, because for instance, in this particular example, this code is for selection sort, and if the program is not sorting your input, then the program is not written correctly. So you would like to know that what's going wrong. Now, in this particular program, what one could do is that one can add print statements, right? I'll show it to you in MATLAB what's happening here. So this is my selection sort program. Increase the font size. Okay, now it's too big. Let me make it smaller. Is this program readable? All right. So in this program, I have an array, and we are calling it A. And it has these numbers 3, 5, 11, and 1. And these numbers are unsorted. And what we would like to do is that we want to sort these numbers using selection sorting. So we take the length of A, and we have some display functions here. And over here we have the loops. In our opinion, we have done everything correctly, but there are some problems in this program. So let me comment out the print statements at the moment. And let's run the program. This is what we are getting over here. The list has not been sorted, and we need to find out where the problem is. So the first step, what we normally do while coding in MATLAB, is that we display the output of our program, or we display the variables by using the print statement. Now let me uncomment these lines. Let's run the program now. Now, what's happening here is that this list is being displayed here before the loop. Then what we do is that we want to display the minimum index after every second for loop, right? So the value of this index is always 4. Now, this value is not being swapped correctly. So what we are doing wrong here is that instead of replacing, so how do we do the selection sorting? We start from the left, right? And what we needed to do was that instead of swapping AJ, we had to swap AI. Let's fix this one here. Now we run the program. and now we know that the list is sorted, right? So if you use print statements in your program, you can display the values of your variables, and you can find out that you have probably done a mistake at one point. So runtime errors, as opposed to syntax errors, they are often hard to fix because variables might cease to exist after function termination. Like if you do not write these print statements there, then your variables, you won't find out that what actually happened while you were running the program. And apart that, this trace printing works for small programs, but it may get confusing for you if you have a large program. Right? So most programming suites offer tools to find bugs in the programs, and those tools are called debugging tools. And how did we get this term bug from? So the term bug is due to airplane testing in 1945, and there was an actual insect, a bug in the engine that was causing the problem. And therefore they assigned the issue to the presence of the bug, and from that point on we say that we have a bug in the code, right? So that's not an insect in the code, it's a coding error. What we can do beyond just trace printing. Let's go to MATLAB again. There is something called breakpoints. So we don't need the print statements here anymore because we are going to put breakpoints. Now what breakpoints are going to do is that they halt your program, right? They can be set at a particular line by clicking on the breakpoint LA in the editor. So in this example, here you can click here, like for instance, I want to display the value of min index. See, I clicked there on line 8 and I got a breakpoint there. So this red dot, this is a breakpoint. Now let's run the program. So what happened is that my program has been halted now at this breakpoint. See, do you see the green arrow over there? So the execution of the program has stopped there, and now I can find out the values of my variables. So when the script is run in MATLAB, it will execute it until the line where the breakpoint is set and execution is temporarily halted. So let's see what happens then. So over here, we have different variables. For instance, we have I. If you want to display the value of I. So right now, the value of I is 1. Okay, so it's the for loop has started from I equals to 1 to L minus 1, and right now the value of I is 1. Then you can check the value of your min index. So I think this is coming from when I ran the program previously. Let me have my next breakpoint. And if I want to go to the next breakpoint, I would click continue. Now the value of min index is 1. See, only one line has been executed at this point in time because my first breakpoint was on line 8 and my next breakpoint is on line 9. So I can continuously monitor this. If I'm going to press continue now, what is going to happen that everything after the breakpoint is going to get executed. So the code, this for loop is going to get executed. The other for loop, which is the nested one, this is going to get executed. Everything after the for loop will get executed, and then the value of I is going to change. And I is going to become 2, and my program is going to again get halted at this point. So let me press continue. And let's have a look in the command window. So let's see the value of I here. See, now I equals to 2, right? So at any point, I can monitor the value of my variables, and one can find out where the error was. And how would you know that you are in the debug mode? So this variable k, this is going to get displayed on your command prompt. And if you want to stop debugging, you would like to press this button that says quit debugging. So here I have quit debugging. If I want to clear my breakpoints, there are multiple ways to clear your breakpoints. One is to click this point again, like this. So the breakpoint is gone. Okay? Let me put some more breakpoints, and okay, so now I have multiple breakpoints. I'm going to click here on that button that says breakpoints, and I can clear all the breakpoints. Okay? So when you are in the debug mode, your workspace would also show the list of your current variables, and if you want to display one of them, you can easily display that. We have already seen that in debug mode, the program is practically frozen in time, and you can inspect the values of all variables at that point in time. So after you are done checking the current line, you can either step to the next line, you can press F7 and you can go to the next breakpoint. Run the program until it arrives at the same breakpoint again. For that you need to press F5, which is called continue, and you can also remove all the breakpoints, which we just did a while ago. And then you can run the program in its entirety. So debugging tools provide snapshots of a program as it is executed. And the individual variables which affect the flow of the program, they can be examined as the program flows through time. So finding runtime errors, they become more manageable with these debugging tools. Right? And MATLAB provides a rich collection of debugging tools. You just need to learn how to use them. So in the practicals, next upcoming practicals, the programs are definitely going to get a little bit more complicated, and it's natural that you are going to have errors in your code, and they might not be syntax errors, and you might think that the program is running perfectly fine, but it's not producing the right output. So you can debug your program using 2 mechanisms. If it's a small program, write print statements. But if it's a big program, or if it has multiple loops in the program, then it is advisable that you should use the debugging tools in MATLAB. Any questions so far? Yeah.
With the breakpoints, when you set the breakpoint, will the program run that code, or will it stop before the breakpoint?
It would stop at the breakpoint.
So before the line of code?
Before the line of code. It won't execute that line of code. And then if you're particularly interested in what is happening at that line of code, you can have another breakpoint right after that, and then you can check what happened at that line of code. So the next thing we are going to study today is importing and exporting data. The process of moving data between MATLAB and disk files is called importing. That's your importing from disk files, and exporting to disk files. So data can be saved in either text, which is ASCII. Do you know what ASCII is? It is the American standard code for information interchange. And what really happens is that so each binary value between 0 to 127 is stored as a character in ASCII. And if you're interested in finding more information about ASCII, you can Google it and have a look at the ASCII table. So text formatted data can be viewed with text editors, but it requires more storage as compared to binary formatted data. We have two commands in MATLAB. One is load and the other one is save for exporting and importing data. For instance, may I have your attention? For instance, we have this matrix A, and first we are going to export this matrix and then we are going to import this matrix. So let's see how we are going to do it in MATLAB. So we have this matrix here, okay? And now we would like to save this matrix in a text file and in the ASCII format. So you need to remember 4 things over here. The first thing is the keyword save. The second thing is the name of your file. You can give your file any name you would like. The third thing is the variable which you would like to save, and the fourth thing is your format. So if you type save, so we have this data saved in a file. This is mydata.txt. So see, this has been stored there. And now if we want to retrieve this data, we need to use the load command. So for reading the data, we just have 2 things. The load command, which is a keyword, and the second is the name of your file. So this data has been loaded again, and let's display it. What did I do wrong here? Yeah, so see, I typed the wrong name. I wrote everything in the small letters, and MATLAB is case sensitive. So this is how I can display my data. So everything has been loaded back by using the load function. For the binary data, you can use the command save file name, and you can have multiple variables XYZ in the file. And if no variables are listed, then the entire workspace is going to get saved. So if you want to load a binary file, you just need to execute load and file name. So low-level file I/O refers to getting data into and out of the program by directly accessing the target file. And low-level file I/O allows a higher degree of flexibility compared to using the high-level functions like load and save. And we are going to see what are low-level file I/O operations. The process of reading and writing is achieved by file identifiers, which essentially connect the program with locations on the disk. So in this particular example, the process generally involves 3 steps. We did have a look at writing files in the last lecture as well. So over here, when you are writing a file, you need to remember the 3 things. You need to create a file identifier, then you write the data, and then you close the file identifier, okay? So what we are doing over here is that FID is your file identifier. And does anyone remember what this W was for? For write. When you want to write to a file, you are going to open the file in the write mode. And we have opened this file. This is called temperature.txt, and we are printing the values of the temperature into this file. And then the important thing is that you need to close the file. This is something I mentioned in the last lecture as well. So when you open the file, you also need to check another thing, whether the file has been created or not. And this is how you're going to check this. If the file identifier is not equal to 1, then you are going to execute your code. But if the file identifier is equal to -1, then this means that there was an error in opening the file, right? It could be that you don't have sufficient writes on the disk. There could be many other issues too. And we already know that one can use fprintf to write formatted text data into the file. So we have written some data on the file, and you can read the file using the fscanf command. Now let's focus on how to write binary data. So here in this example, we are entering and recording any number of names and marks and writing them as binary data to the file. So first of all, we have defined a variable which is name length, and we have set this variable equal to 10. And this means that we have assigned 10 bytes for the name, okay? Then we have defined the file identifier, which is the name of the file, and for binary files, we have the name like this with steric.bin. For text files, we have .txt files, okay? And then we open this file identifier in the write mode. The next thing is a simple string, and in the beginning we are going to assign it a question mark, because later we are going to use a while loop and check the condition. If the string is empty, then we would like to break out of the while loop, okay? So it's just a dummy variable which we have assigned here. Now in the while loop, what we are doing is that we are checking if the string is empty, then the while loop is going to terminate. Now why have we put this condition here? Because if you look at the line after the while loop, here we are asking the user to enter the name of a student, let's say, and later we ask the user to enter the marks. So for instance, if the user does not enter any name and he just presses enter, then this means that the string is empty, and this is kind of an indication for this particular program that the user does not want to enter the names of any more students. Probably the list has exhausted, and so the program, the while loop should terminate over here, okay? So so this is about the input of the name, and then if the string is empty, if the string is not empty, then we are going to check one more condition. Remember that we defined the name length in the beginning, that it should be 10 bytes. So if it is more than 10 bytes, what is going to happen then? Then this variable name is going to get everything from the string, which is from the beginning of the string until the 10th character. Okay? And everything else after that is discarded. So if somebody has a really, really long name, we are going to discard everything after the 10th character. And if the length of the name that has been entered is less than or equal to the length of the string, which is the else case, then we are going to assign a string to the name, and we are going to add some padding blanks in front of the name. And after that, we are going to write this name to the file. Then we get the marks, and we are going to write the marks to the file. And this would continue until the user just gives an empty input, and the program is going to end. And before ending, we are going to close the file. So let's have a look in MATLAB. I've already created this file, okay, and let me run the file now. So first of all, I need to enter the name of a student. Let's say I write my own name. I like to get 100 out of 100 marks. Okay, so the next student is, let's say, John Doe, maybe 80 marks, and the next one would be Casper. And let's say I only have 3 students in my class, and now I'm going to press enter. This is, see, I have only pressed enter, and this means that I do not want to give any more input. Now, what has happened is that in marks.bin, what my program has done is it has written everything in that marks.bin file. So let's read that file. Okay. Now, how am I going to read the file? Again, I have 10 bytes for the name. I would like to open the file. We did this in the lecture when we did the input and output functions last week. We do need a file identifier. We have the file name, and this time we are going to open the file in read mode. So the first thing which we are going to check is the end of file, because if you already have an empty file, you can't read anything from that file. And once the end of file has been reached in a file where you have some data, you don't want to read beyond that point. You can't read anything after that. So this function FEOF, so EOF is basically end of file. In some other language, just we have this EOF, but in MATLAB we have this FEOF. So until we don't have the end of file, we are going to read this file as a binary file. We convert the name into a character string and the marks as floats, and we are going to print the name and the marks in this format. And I'm going to run this file now. This one. So see, this is what has happened. Now, my name has been truncated because it was more than 10 characters long, right? And in front of John Doe, so John Doe has 8 characters, including the space. 2 blanks have been inserted, and in front of Casper, a certain number of blanks have been inserted as well. All right? Any questions? So we have already covered these things, that you need to make sure that the string is within the imposed length. This is what this if and else statement was doing. So always remember that if you are reading a file, you need to open the file in the read mode, and if you are writing the file, you need to open the file in the write mode, and they are denoted by R and W respectively. So we have seen our own sample output in MATLAB. Now, what about matrices if you want to read or write matrices? It isn't much different from reading and writing files. Let's try that. Let me see. Okay, so again you need a file identifier here, right? So this file ID, you can call it anything. You don't always have to call it FID or file ID. You can have your own variable name which you like. You can put it here. So once you have the file identifier, what you're doing here is you're opening a file in the write mode. And when you want to write something on the file, you need the file identifier, your variable, and the type of the matrix, right? Here we have a double. So do you remember what MAGIC does? It creates a matrix. Right, so here we wanted a matrix of 3 by 3, so we have a matrix of 3 by 3. And let's assign so that we know what we are doing. Okay. And now the first thing which we are going to do is that I'll do it in command prompt. Right, we have opened the file. And we would like to write this matrix A, and then we need to close the file. So we have closed the file. And if you want to read the file, and you can read the file using the fread command. So when you want to read binary files, you need the fread command, okay? And here you have read the file, right? So this is how you're going to write, read and write matrices in a file. So what we covered today, surprising, the lecture is ending pretty soon today. We have seen that bugs are almost unavoidable in program development. I would strongly encourage you to use the debugging tools when you are coding your third practical, especially in the first part of the practical. And MATLAB provides a very rich collection of debugging tools to locate and fix your bugs. Further, we also saw that it provides high-level I/O via the command save and load for both text and binary formatted files. You can save your data and then you can later use the same data again by using the save and load commands. And the low-level file I/O is accomplished by fopen, we did fprint, fread, fwrite, and fclose. Try to work with these functions when you go home. Try to implement small programs using these functions to get an idea how these functions work, and do use the debugging tool. So that's all for today. Any questions? Any questions related to the practical or the tutorial? Okay, so that's it. Thank you.